Example on optimization. Not the easiest topic out there, but if you set up the equation, it should be good to go. I know that's harder done than it is said. Okay, so we have a window here, and it's adjoined by a semicircle on top of an ordinary rectangular window. So let's just draw, that's not what I wanted, undo. So let's just draw a rectangle, okay? And we also have a semicircle. This looks like a semicircle. Okay, seems about right. So put this over here. That's pretty good. Okay. A window is constructed by joining these together. Find the dimensions of a window if the maximum area of the total perimeter is, find the dimensions of the maximum area if the total perimeter is 16 feet. Okay, so this entire perimeter is 16 feet. So what is the perimeter? Well, let's say that this is a width of x and a height of y, which means the radius is x over 2. Okay, so the perimeter, which is 16, equals, what would that be? The perimeter would be 2y, 2 y's, 1x, and the perimeter of a half circle, this is a semicircle, is 2 pi r divided 2. So 2 pi r all over 2. So that simplifies to 16 equals 2y plus x plus pi x over 2. Okay? Now it says find the maximum area. So area is equal to x times y plus pi r squared over 2. So pi r squared, and I only want half of it, over 2. Okay, now we want to maximize area. I then need to take the derivative of area, but the problem is I've got x's and y's, and I need only x's. Whenever you're doing optimization, it's very often that you have two equations you're dealing with, but you reduce it down to one equation with one variable. So you can see here, I can solve for y if I want to. Actually, I really want to. Okay, so 16 minus x minus, let's see, pi over 2x all divided by 2 is equal to y. I think I can simplify that a little bit. 8 minus x over 2 minus pi x over 2, which is also equal to 8. I'll just take out a minus x, so x times 1 minus pi over 2. Let me think that through again. If I distribute the x, I get negative a half, which is what I want. Distribute the negative x, nope, that needs to be a positive. Okay, distribute the negative x, I get the same thing here. All right, so this is equal to y. Y equals, and that will be very convenient right there. So area, back to blue, area is equal to x, 8 minus x times 1 plus pi all over 2, and parentheses, plus, okay, so this is going to be pi x, that's pi over 4, so that's over 4, and that will be over 8. So the whole thing's over 8. All right, so let's go to our calculator. We can use calculators usually for optimization. Get rid of that. All right, so I have x parentheses 8 minus x parentheses. Let's see, parentheses 1 plus pi To guarantee that it's on the top, I need to put that in parentheses. Divide 2. Okay, that closes the parentheses there for that x, and then I need to close this parentheses, I believe, one more time, and then plus pi x over 8. Let me just review this again. So I think it's right. Yeah, okay. So window, let's go 0 to 10, and then we'll go zoom fit. All right, we want maximum area, which looks like it's right there. So we'll go second calc maximum, which is number 4. Oh boy, stuck me way over here. Okay, enter. Enter. Okay, x is, let's drag this over. X is this. X is 2.02, and y, that's not the same y. This y represents the area. So the best x value would be 2.02, and if I plug in x right into there, I find out what the y value is, and those would be the dimensions. So there's your optimization problem.